check. Okay, TCP-IP OSI model. Yep. Yeah. TCP-IP OSI model. We going to see quickly OSI model. This is the little theory class, but we going to smartly going to cover this theory, and we will understand how TCP-IP and OSI model work frame. First, TCP-IP and OSI model. TCP-IP leading OSI because OSI came later on in 80s, in between the 80s 90s. Okay, they're the requirement when they want to open standard the things. So TCP/IP, the same kind of TCP/IP, not exact TCP/IP suite, but the similar suite they have in IBM and DEC and other vendor accumulatively they are working on those somehow equal to TCP/IP but not exact TCP/IP. Okay, so in 1980s, this is about 1980s. In 1990s, what happened? All the other vendor come with the TCP/IP only the model. Wait, let me open my work here. Yes. Okay, so here, give me 2 minutes here. I forget to connect my electronic pad. Yes, it's working. I hope so. Yeah. Yes, here. This is at the very beginning we had this IBM, DEC and other vendor accumulatively they are working for somehow TCP/IP, not exact TCP/IP model what we have today. Later on 90s, all the other vendor come with the TCP/IP, but IBM and DEC they have different architecture, but later on in 2000 they come with the solution. And the Cisco has announced in I think 1995 1998 first time they announced with the CCNA course that time. So Cisco come with that. So 2000 there is only TCP/IP. OSI model preferably they just for study purpose, there is no practical concept. We will see if we will do the lab header, you will see only the 4 layer where the TCP/IP working, others are the encapsulated. Okay, we are not going to spend much more time, there is nothing about this. Come to the, there is two terminology you should remember and you should use this terminology frequently while they will ask you the TCP/IP questions or related to OSI model questions. That's encapsulation and decapsulation. Please use this terminology. This is going to give you complete information about the model layers wise. So we have 7 layer in OSI model, we have 4 layer in TCP/IP model. So we're going to do lab for each and every, don't worry. So we're going to cover the right now quickly just for understanding so that we have theory part. So we have application layer, presentation layer, session layer, these accumulatory called application layer in the TCP/IP. Where is the transport layer? Here also transport layer, and the network layer we have internet layer, and then data link layer and physical link layer, it's come with the internet interface. Okay, so we have 4 layer. In that they have defined beat and frame, packet, segment and data. So data is the actual payload. The word terminology come with the payload, actual payload. That, so you, how you have to remember these things, the payload is a data and that going to be encapsulated with the TCP/IP header, or you can say transport header. Transport header encapsulation come with the segment. Again IP header encapsulated, then packet, then Ethernet header encapsulated, then frame, and the frame going to be break into the bits and it's going to transfer over the as a electrical signal or optical signal. So it's going to transfer over the optical fiber as a optical signal and the electrical signal on UTP and other media. That's so. So encapsulation and decapsulation, while we receive the electrical signal, they're going to assemble as a frame and the decapsulate. If you remove Ethernet header, decapsulation of Ethernet header, the payload will be the packet. Again, you're going to remove or decapsulate your IP header, then it's going to give you segment, and again you're going to decapsulate your transport header, that's a TCP UDP. It will be your actual payload. So whenever you're going to explain OSI layer versus TCP or the interview, you're going to give, you use the encapsulation and decapsulation terminology, and we have four things: frame, packet, segment, and we will do the lab, and today we're going to see. So what are the example we have? Quickly we will see. These are the example we frequently going to study and do the lab on that. So we have HTTP, Open ADR, and ICCP. These are the applications, though so many applications are there available. So for presentation layer, we have compression, decompression, encryption, decryption. Session layer, we have RCP, peer-to-peer, SCP, tunneling. These are the examples. Transport layer, we have example TCP UDP. Apart from RCP and other stuff, we have other network technology. We will come to the OSPF, and they are using the proprietary one. Now we have network layer, ICMP, IGMP, ARP. We will do the lab and we will see in detail. Now Ethernet, entire CCNA, we're going to concentrate on Ethernet technology. We will start from header layer 2, how it's formation of header and how it's going to decapsulate and encapsulation method going to work. So till here it is okay. We should move to the next slide, everyone.
Yes.
Okay, thank you. Next we have, wait. Let me pick up big one here, otherwise it will keep problem. Okay. This. Okay, come to next topic. We have, yes, next topic we have overview of TCP/IP networking model. Here we're going to see the logical protocol. On this we're going to spend entire CCNA and we will do the lab for each and every protocol. So better we will going to introduce today what are the protocol we're going to do lab for that. So first come to layer 2. Layer 2 we don't have lab, so we have only theory part we're going to cover here. So layer 2 part, if you see physical protocol, we have physical protocol Ethernet, entire CCNA, we will work on that. Tokening, I given you work note. What is tokening? This is a LAN technology and second favorite technology. If the Ethernet is not there, the competition with the tokening. There is a ring where they're going to pass the token, and this is developed by the IBM. That's why IBM having different infrastructure of working with the LAN technology. So second, if Ethernet is the, what is the alternative of Ethernet we have today also, that's a tokening, and this is proprietary of IBM. Now frame relay, we will do the lab. It's working on DLCI. We have quite good lab for this, and it's depend upon you. If you want to do further more lab, we will do that. This ATM is asynchronous transfer mode. This is used for WAN technology. This is a specific use for WAN technology, not for LAN technology. So LAN technology, we have tokening alternative, but today we are going to study and we will do lab for Metro Ethernet. We will see how Ethernet also compatible with the WAN technology or MAN technology, MAN and WAN technology. Okay, but we have for WAN technology, we have serial connectivity, point to point. Apart from that, the other shortcoming technology like Sonnet is nothing, it's a synchronous optical network. I have given you questions answer for that. This is there is a legacy few things which is not uh, I'm not going to cover in CCNA, but you should know. So I'm going to share you, let me finish first this. I'm going to show you what are the things I'm going to share you. After that, you go through those things and you can post me questions on the Google class. SDS and PDS, these are the technology throughout the world going to means are using. The SDS is a synchronous digital hierarchy, and this is plesiochronous digital hierarchy. Plesiochronous and digital, these are the technology, whether it's a use for the FDDI and other stuff, other technology. Okay, but this is not so compatible, where the SDS is synchronous and clocking rate is very good. So layer 2 infrastructure, it's SDS, and I given you questions answer which is not covered in CCNA, but I given you the all the detail. That's more than enough for your exam purpose. Now come to the wireless technology. We have two wireless technology throughout the globe. That's a CDMA and GSM. GSM and CDMA, anyone know what is the CDMA and GSM? You have heard about the CDMA mobile phone and GSM mobile phone.
Is it
Anyone?
wireless technology?
Hello?
Yeah. Hello. Is it related to wireless technology?
Yes, is it really? It's a
So
layer
yeah,
2 wireless technology, CDMA and GSM.
Tata
GSM,
Docomo were CDMA phone, I think.
yes, right. That's CDMA, Tata Docomo, and GSM. Today is we are going to globally going to follow the GSM SIM. This is a global SIM management GSM. So this is layer 2 technology, and CDMA is the old one. We going to study CDMA theory part, but I'm not going to cover in CCNA, old CCNA, that's part. So I given you the compare about the CDMA and GSM. So let me show you how I'm going to share you guys. Yes, this is the part what I'm going to share you. I'm going to quickly show you that I'm not going to take the class this much of theory here, and you can prepare, you can shoot the questions whenever you need that. Okay, now come to this part. See, in this is a work note. I'm going to share you what is the tokening protocol here, detail given, what is the ATM, the diagram, and is it the ATM is WAN technology. Sonnet, what is the Sonnet, where they use, what are different for the Sonnet and Ethernet. So Ethernet, just I want to show you what is the Ethernet main advantage over the Sonnet or any HDS means digital hierarchy do you have. Here there is no overlap. Can you see? Means they need the 300. They are very rigid infrastructure, you cannot check. But here we have flexibility, you can overlap the technology. Even though we have 200 MB link, we can overlap and we can use this technology of override. This give the flexibility, and that's why Ethernet today is most popular. We will come to in detail in that. So I will share you, this is what is the PDH, Plesiochronous digital hierarchy, how it's different from HDS. I given you the differences of these two. This is more than enough to understand. Clock is not synchronized, clock is synchronized throughout the network, and these are the layer 2 technology. You should know that solve, and GSM and this thing. They are not going to ask you in interview because you are very high level, you going to study higher. You are talking about the automation layer wise, higher layer. Now come to the next. So logical protocol here, logical protocol, let's see quickly. We're going to do all the lab. So we have IP layer, we have ICMP, ping test and other stuff we're going to do throughout the lab. IGMP, we have multicast very little bit. I will show you how to associate with the multicast and how you're going to test the multicast with the IGMP. Then ARP and reverse are, as soon as we will start Ethernet 2 layer 2 technology and lab, we will do start from the ARP only, how the ARP resolution and MAC going to be resolved through the layer 2 and layer 3. Okay, this is the IP header. And come to TCP and UDP. We have a series of list of protocol on which we're going to do the lab, and we will understand the header wise. We will do all the lab on the, we will understand the header wise. So quickly, Telnet, if you see Telnet and SSH, tell me what are the port number? 23 and 22. SSH used for 22 and Telnet used for TCP. And what about FTP? FTP 2021. SFTP and SCP both are using the SSH port only. Always you remember. Okay, and they have different type of header. Okay, we will see. Then we have SMTP, POP3 and IMAP. We will do the lab SMTP and POP3. These two we have lab. And today we're going to do the lab only for HTTP and HTTPS. Means we're going to do the see the header of the 80 and 443. Agree guys? So today we will do the lab for HTTP one port only, 80 and 443, means both the port we will do. Okay, and then BGP 179, TCP, this is example of TCP, and again UDP we have DNS, SNMP, syslog, NTP, wings, and then RIP protocol. So all the lab we will do. To please remember, this supposed to be in your fingertips with your port number. Okay, and the detailed theory part, 2 line and 2 points or 5 to 6 points for each protocol I will give you in work note. Okay, go through. Once you read, you will able to very easily you're going to prepare this. Any question till here? No, that's okay. So you understand TCP and UDP. You have major number of protocol in your hand now. Revision. Just revise here and quickly we summarize this today's class, and we will jump to the some exercise. Okay, so we completed my TCP/IP. Now first, whenever the questions come from or interview asks you regarding the TCP/IP and OSI model, you use two keywords: encapsulation, decapsulation. First, these two keywords, and you talk about the frame, packet, and segment, and use decapsulation, encapsulation terminology, and answer in that format only. Okay, we have 7 layer. We already revised: application, presentation, session, transport, network, data link, physical link. This is for theory purpose. We have application, host to host, that's a transport layer; internet, that's the IP header network layer; and network interface layer, layer 1, that's a data link and physical link is combined. So we have protocols SSL, and ask you what they do and what the SSL do. That's a certification presentation. You had certified HTTP and HTTPS, that show you whether your website is certified. Then SSL come with that. ASCII, this is a representation again. Okay, now TCP, UDP and everything, you know, that's remaining. So at least you should remember these HTTP, POP3, the examples of protocol for applications, and TCP, UDP is transport application, and internet we have IP, ICMP, IGMP. Because if you remember ICMP, of course, so IGMP you keep remember this multicast, this unicast, and data link and physical we have data link. We're going to study the Ethernet, Metro Ethernet, and other technology in that, and Wi-Fi. Of course, we have clear division which should good for TCP-IP OSI model, and remaining thing detail I will give you in work note. Go through, that's a theory part. I don't want to spend much more time. Anything you want spend more time, you want more content, guys? Anyone? Okay, should I move next?
Yes.
Yes.
Okay, come to this next. Here guys, everyone, I want please participate. Today you understand this magic mathematics of 8-bit entire CCNA, apart from after CCNA, CCNP, CCI. If you do also, you will understand the logics and how you going to complete the any. You have control of everything. So let's quickly understand this, and I spend quality time over here. So 1 byte is nothing, 8-bit, right guys? Help me there.
Yes.
Here, okay, 8-bit. So we understand the how 8-bit we have to represent. I already given you format. Always you make 4 pair, you make 4 pair. Okay, so you got the 8-bit, right?
Yes.
Right. So today what we're going to study, we have to be expert on all 8-bit. That's mathematics of 8-bit. So we're going to see if we have expertise of 8-bit. By looking on the bit only, I can say that this is an even number or odd number. Anyone, do you have idea how? Okay, we will see that.
Last bit.
Okay, last bit, very good. So we will see by looking on the last bit, we can see that. I will come back to on that, and there is a very good mathematics behind that. Recursive mathematics, recursive matter of one's complement, and we will achieve any kind of what number quickly. How we will see standard bit position. Let's understand the standard bit position. What is the bit position is let me open Excel sheet. That's very easy to work, and I will show you easily rather than writing stuff. Okay, remove. Are you able to see my Excel sheet? Okay,
Yes.
you guys also work in Excel. That's a very fast and easy. So what is the bit position? Let's do it fastly. So this bit position is 1000 and all are 0. Are you agree? Are you able to see my? This is the right bit position. So I make the 4 pair, and I given the space, and again I make the 4 pairs so that I can quickly get the result. This is 1. So bit position 64 01 00 0000. This is my 64. 32. Can you see how fast I am giving the value of binaries? Okay, 32, and then we have 16, then 8 0000 then a space 10000. See how fast I am doing this. I will show you. You can do entire work like this for higher class, for all the subnetting and everything you will do. And then 000, you have 0010 for 2, and for 1 you know 0000 and 0001. So how many minutes I took? Even not minutes. Can you see the bit position for 1? They keep on changing, and this table we got, that's a standard table, right guys? 2 to the power ka table. Everyone till here comfortable?
Yes.
Yes.
Okay, now next subnet table. You have to no need to remember this subnet table. Subnet table giving the same bit sequence, but here what we are doing, when our bit is moving, we are making disable these bits, but we have to keep enable and we will get the subnet. We have to keep enable bits and we will get the subnet. Let's see this value 1000, sorry, a space 000. Got it. Now next 192. So we have to 01 next tha, lekin but we have to do 11. We should not disable the bit, and that's give you 192. Means 128 plus 64, 192. So 2-bit enable regular, it will give you second subnet, and third is 3-bit enable, it will give you 224. And this table you have to remember. 4-bit enable, it will give you 224. How it's coming? It's a very easy. 128 plus 64, 192, plus 32, 224, plus 16, 240. So 128, 192, 224, 240. These numbers going to help you throughout the subnetting. Next, we are going to move the bits. We're going to move the bit and enabling the bits. The 5-bit is enabled. Now we are going to move 6-bit, and again we have 7-bit enables, and then we have all the 8-bit enable. Clear guys? Now if you understand these two, then let's come the ones complement. What do you mean by ones complement? That's the best feature I'm telling you, that's going to help you for, because you have to expert for 8-bit. If you have 8-bit expertise, IP addressing will be in your tips, on your fingertips. Once IP subnetting, then other like ACL, wildcard, everything going to be on your fingertips. So let's step by step you study. So we know the pattern. We know the pattern of the what? Of the binary code. If we have a standard this table, means no need to calculate anything. If this number comes to me, I will give the binary code ready-made, right? Omkar?
Yes, sir. Correct.
Okay, so we have ready-made binary stuff for all these numbers. Now one's complement is says that as soon as you get first one in your bit position. So let me take this example, this one. What is LSB? LSB, you always start from LSB and goes to MSB, from right to left, from right to left. So lower position LSB, max position MSB. So you start from any number reading from LSB. So once you start from LSB, one's complement say first one. Once you receive first one, you make it 0, remaining all ones, it's give you that number -1. समझ में आया? Let's do. क्या बोल रहा है? Rule says that whatever the first one, where I got the first one, 0 0 0 0, first one at the here at this position. So what I will do, I will do 0, that 1, and remaining all the 0 become 1. And that's the value of 127, means you will get -1 value. Yes, Preeti, you asked me any question?
No, you asked the positions of one
Yes,
server saying
okay,
ML.
thank you. Got it. Yeah, so 128, how do you get quickly 127? Means if we have all these table ready-made, means if we have one's complement ready-made. Let's do all for one's complement. What is the position? 7th position is, so I will keep 0, I will make 7th position 0 and remaining all ones. So I got the value of 63. Same way I got the value of, tell me here, I got the value of 31. I got the value of now 15. How easy? Tell me, it's a damn easy or not? By doing, by calculation by the 7. I got one's complement. I will do little bit complex number one's complement. Please be with me. You understand this? It's going to help you throughout your networking, guys. Ask me question if you are not understanding here, because this is a basic one. Tell me one's complement this, because this going to be 0, this going to be 1, this is 1 and 0. Of course, this first you got 1, then it's going to be 0. That's all. Ask me question. Yes, clear, guys? One's complement.
Yes.
Yes.
Okay, now come to the ones complement this. That's it. Then that's easy. We already done 0, 1, 1, 1 and 1, 1, 1, 1, 1. Now tell me how we will do ones complement. We have this. So what will be the, anyone, one by one I'm going to ask you. First, Sagar, tell me what will be the answer.
Yeah, 1 0,
Very
and then
good.
all will be 1.
Wow, excellent. Yeah, both easy and just you do. This is going to be give you your ones complement, means 191 value. Okay, next, Preeti, can you give me answer?
Sir, can you explain how that
One month.
Okay, very good.
one zero?
See here, what's the rule says? You have to first identify first one. So here 000, what is my first one?
Yeah, okay. Yeah.
7th. I'm not worried about, once I will get my first one, remaining we will keep same. So I keep same. I will do my first one 0. Same thing I have done this. Please practice it. So first one 0, remaining all the 0 going to be 1. That
Okay.
give me the value, whatsoever value, that -1.
Okay. Got it. Yes.
Okay, great. Got it. So now, yes, Preeti, can you give me the answer?
It is 110
110 and then
1 then 111.
all ones. Yes, because we got clear. Now again I will get 111 first one 0, remaining all 111. Omkar, are you comfortable now?
Yes.
Yes,
Getting
you
it.
got it, the logics. So 1111, we have to identify first one going to be 0, remaining all the ones, zeros going to be ones. So we have ready made binary for all these number. No need to do any calculation. No need to do any calculation. Sorry, here it's already 1 1 and this first one is 0 0. That's, and then 53 111 1 space 11 and 01. Now last one, tell me here 255, what will be value? Sorry, here I wrote wrong. 254 I have to achieve. Now tell me what will be the ones complement quickly. The
All
first
one,
one
last
going to be
0.
0.
Last
Yeah.
one will be 0 here.
Yes, first is a 0. So you see your rule going to apply universal. So you're always supposed to be your rule always universal rule. Okay, guys, clear? One's complement.
Yes.
Yeah, it's a magic. It's so good. Now, so any number we will come to quickly. You take any number of 8-bit and we will do faster calculation. Okay, today we will see. Now, before going that, do you remember the 16 table? No, I don't know 16 table. 16 table 16 time means 16 10 जाके बाद 16 11 12 16 13 16 into 14 16 into, so this table give you the awesome 16 table multi, and this table going to be very helpful, guys, while you going to do the better. If it's a bad practice, you remember this. How easy. You should, your all the last bit, first 4 bit from LSB, first 4 bit going to be reserved as a 0, no need to change, and you have to changing only the MSB 4 bit. Okay, so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, everyone. So if you start from 1 to, if you write from first 4 digit from MSB, it will give you 16 table, and it's going to help you understand you quickly writing any number. 16 32 48, just 16 table. 16 32 48 64 18 96 1112 148 144 160 176 192 92 208 224 240. These 3 number, you know that already. If you don't remember, that's also not going to much, but that's going to give you quick, very quick calculation. Let's practice on the quickly few number on whiteboard. We will do practice on whiteboard. Okay, so yes, so take any number. Anyone give me any number. No. Okay, so let's, from this is the exercise what I gave you, right, guys? Everyone.
Yes.
Yes, so better we will pick up. So tell me, what is the decimal number value of first? So how do you do? That's easy. If you remember, see, what is the value of this first 4? 8 plus 2 plus 1. 8 plus 2 plus 1, that's 11. And what is the from 16 table? What is the value of 16 table? Do you remember this? This 192. This is from 16 table. If you see, this is 192. No need to remember that also. If you just, you want pattern 128 64 128 64, from here also you can going to get to see. Okay, you're going to see this from here also. So here also you have I came to, okay, without whiteboard. Yes, now I am. So you have this 92 value, and you can do that. That's a very easy. You, what is the value now? Tell me. 11 plus 192. It's very easy.
203.
Thank you. 203. That's a quick answer they're going to give you. So if you have this ready made in your, then it's going, let me quickly take another one. Give me what's the value of this. This is all ones. It means, if all ones means ये bit का value ले लो. First you consider this value. So this bit is one's complement, right? This bit one's complement. So this bit value is, what is this bit value is 16.
31.
And no, yeah, this value is 16.
Yeah, the total
16
is 31.
means we
16 plus
have
8.
15 plus 128.
Right. It is one.
Right?
Yes.
Right?
Yep. Yeah.
So what is the exact value?
144.
15 plus this.
16 now. It is 16, right?
No, 16 value of this, ma'am. So all 15 was complement.
Oh, sorry. So yeah, it's
Okay, that's a 15. So 15 plus this. So
40.
143. Thank you. You are getting quickly now. So now next, this is easy one. Yeah, this is 4 value. And come to this one. I want this one. So if you see 16 table, so you have EG 160, means you have ready made, and then you have EG1 10, 8 plus 2 10, means 170. See how quickly I'm giving you answer. Let's see this what is the answer of this. So what is the, if you have this table, if you have practice with this table, 1010, where is the 1010? Go to little up, 101 80, and then we have anyone 4 5 85. So you're going to be expert very fast. You're going to give answer. So if you are practicing this, okay. If you're not practicing,
1010 is 160, right?
yes, 10101 means you can add here also. This is 64 plus 16, that's 80, and this will give you 5. 4 plus 1 5, 85, right guys, everyone? Yes, no?
Yes.
Okay, let's do quickly for this practice. For this number, I'm going to type here. I'm going to keep my keyboard ready. What's 213? So 213 near to what value? Anyone? Near to which value on this table? On this table, near to what value? We have 213, means 223 minus 10. 223 minus 10. So I have 223. So I will write very easily 223 value. One's complement of 224, right? So it's a damn easy. So one's complement, suppose I did not remember everything. Just I have 224 value. I wrote that. I need to achieve. So how you are going to process this? We will do the ones complement. What going to be ones complement for this? So 1 1 0 1 1 1 1 1 1. Okay, this is 220. What is this? 220. Bolo yaar. 223. Now 223 minus 10 means you can do 8 or 0 karo. You do this, convert 8 into 0 and 2 into 0, and this is my number for 213. Let's verify this. 128 plus 64, what will be? 192, this value, plus 16, it will give you 192 plus 16, so 108, plus 4 12 and 1 13. Okay guys, you can do like this also. Clear everyone? Yes, no, kuch to bolo.
Yeah.
Yes. And now let's take big number 252. 252 is very easy because we have 254 in my hand or 255 in our hand. 255 1111. It's easy. 255. Now I have to achieve what? 252. How much you have to minus 3? So just remove 3. 0 0. This is my 252. Agree?
Yeah.
Okay.
That in calculation as well.
Yes, ma'am. Preeti.
Yeah, I'm saying that 252 is like a standard value which we have in table as well.
Yes, we have in table also. Yes, right, on the subnet part. Okay, to till here clear guys. So we will do the lab. I will give you, please practice. I given you already. No one practice. I think only Pavan has submitted the complete, not half of things. He also come and I want to what error he given the right answer, or just I want to the style of writing he should not. Suppose he given me ninth answer, everyone you are okay, wait here. Okay, suppose he given me ninth answer, how he gave me number, he given the answer like this, he given 8, he given 8001. How many say this is right or wrong? Value of 9. It's right guys, or wrong?
Right.
Yeah, it's right. But always you give answer in 8-bit. Always give your answer in 8-bit. Why? Because you are going to do the things in IP, Mac and other stuff. So what is the best practice of answering this? This is the best practice of it. So whenever you give writing, suppose I can remove these zeros, but I did not remove these zeros because I want to practice everything in 8-bit. Be expert in 8-bit. Everything you write in 8-bit. Today you understand we have to write the everything in 8-bit. Then you can enjoy for summarization, prefix filtration, wildcard filtration, BGP may when you going to do other byte filtration, bit filtration. We will see that. Okay, guys, still here? Comfortable, everyone? Yes, no, we should move
Yes.
next. Yes. Okay, so practice it and give me. I given you let me I given you all this list hacks, and this hacks number always you represent. He answered me decimal to hacks. I given number this way. If you see the register value, it's coming like this. I given there is some purpose. Whenever you go for interview, you say that in this manner. You do best practice. Okay, so all these I given you already. Please go and practice in Excel book. You do and submit your lab and post your query if you have any. Okay, and follow this. I am going to share you this complete table. Please follow it without do practice. Means in once a month or quarterly means once a year also you practice this number before going for interview or anything. That's more than enough. You're going to recall. Okay, clear guys? I'm going to move next. What is we have? So standard bit value, we saw that, and this is okay. Wait. Okay, we saw this standard bit value and come to the subnet table. We have done calculation. Once complement we saw dot decimal format. We will see in the next class when once we will start the IP addressing. Just quickly before that, let's see that IP addressing, if it's already given topic over here. So decimal format. Decimal format. Not given here. Okay, we will see decimal format. How we let me play. Okay, here decimal format. Dot decimal format. What do you mean by that? We have 4 octet. How many octet? Dot IP representation. 8-bit, 8 bits, and again 8 bits. So what we going to study today is 8-bit expert. Means if you going to be expert in 8-bit, you're going to take care about all the 4 octet. So we have dot decimal format of 8-bit. So you have to be expert in 8-bit. You're going to be expertise into the entire IP addressing. And next class we have IP addressing. We're going to start on that. So this says same thing. That's a ones complement dot decimal format. Okay. Now come to next, we have recursive use of one's complement. Yes, I told you I'm going to show you what do you mean by recursive use of. So let's see, understand these 2 points now. Recursive use of one's complement. If you keep on using, you will get the even and odd number. If you keep on recursive use of one's complement of any number, you will get the 1 and 2 format. Let's see what do you mean by that. I'm going in this. I'm taking this example again. Okay, I'm going to take this example again. So suppose this is the number, first number I'm taking. Now I'm going to take example of this. That's so what is this number? By looking on that, I can see this is the even number. How? Everyone, guys.
Last digit is 0.
Yes, if last digit is 0, that's a even. If the first means last digit is 1, it's odd. This will be odd. So while you are writing the code, your code will be easy, because you technical guy, you know the binary of any number. If it's end with the 1, so if you have binary conversion coding ready, to just you call that function, run that binary, and you just give 2 line of code. If it is a 1 odd, if it is a 0, what is the even? Okay. Now recursive, what do you mean by recursive ones complement? If you do ones complement of any odd number, it will give you even. If you do ones complement of any even number, it will give you odd. May clear, guys? Let's do. This is even number, we are going to ones complement. What will be the ones complement? 0 0 0 0 0. First one's going to be 0 and then 1 1. This is even number, sorry, odd number. Now we got, agree, guys?
Yes.
Now you do one's complement 0 0 0 0. First one going to be 0. Now I got even number. You do one's complement 0 0 0 0 0 1. I got even number, sorry, odd number. So each and every time if you do one's complement minus 1, means it will give you keep on even odd, even odd, even odd, even odd. Clear? That's I want to explain you here. So let's remove. Come to Octet expert. Yes, now fastest way of IP addressing and subnetting. So we're going to do the fastest way of IP addressing and subnetting next exercise. So I'm going to send you the exercise for this. Please do some practice. Already I have sent you. Do the some table. I will give you table. You need to complete that table. Clear, guys? Any question till here? I should move for the lab now. Yes, no.
Yes.
Yes, sir.
We are good. Okay, thank you, guys. Lab. Yeah, today's lab is very important. You're going to remember, and from this lab we are starting the header. Means each and every lab from today we have to study the header. By looking on this, anyone, today's lab is for what? First, you understand, we want to see in my header, while I'm doing the lab, I want to see the header part. Okay, it's 10 o'clock. Okay, this part this is 443. This is HTTPS. We're going to study the header detail. We have TCP/IP next couple of class later, CLI and other. We will comfortable with the L2 and L3, then we will do again coming for the header class for TCP and UDP and few more header we're going to do in detail. This is the HTTP. This is the source port and destination port, and how it's going to swap for out layer. So you try to, today we're going to see what doing by in layer, what doing by out layer, how you have to study the layers. And this is called segment. Okay, this is called segment lab, I told you now. And then we have encapsulation, and then we have what? IP header. So in layer, what going to be happened? Encapsulation, decapsulation. And out layer, what going to be happened? Encapsulation or decapsulation. We will understand that. And then we have Ethernet layer header, and we have physical layer 1. So layer 1, layer 2, layer 3 and layer 4, and the IP address and other stuff. So let's start doing lab. So we have lab for HTTP and HTTPS. So career, what we have lab today? Career guys, should I start your lab?
Yes.
Okay, let's quickly do lab, because no need to waste your time for setup of the huge lab and running the packet tracing and other stuff. So come to the terminal. Where do I get? Okay, here. Go to terminal. Meanwhile, first erase this stuff and run packet tracer now. Packet tracer. Please download packet tracer if you have any issue. Post, because this is very lightweight. It's not going to hang your PC at all. Quickly we will do. So what is we have lab? I'm going to take one switch, one server. I need HTTP server, wave server. I have to do the setup of the wave server. I took one server and a couple of PC, because for testing purpose I need couple of PC. So one laptop, one desktop, and I will take one laptop. Okay, that's a small lab. Let's understand the how we have to study the header today. So I'm going to connector will be the straight through cable, because these are the so just control and click this, so I can connect multiple wire over here. This is first port I connected, second port goes to desktop fast Ethernet, and third port goes to the laptop. So quickly we set up lab. That's the beauty of the packet tracer. Now we will start doing our lab. So before that, let's configure the IP. So this is server part. I'm going for desktop and I'm giving IP, static IP I will give 192.168.1.111. It's very easy to remember. 111 is the IP of server. So I will do the ping test. It's because the connected media is connected, so we will do quickly ping test. Ping 192.168.1.111. That's working. Sorry, this is the wrong one. I given 168.1.111. Okay, it's working fine. Great. So my server is set up. Now come to the desktop. I will give same subnet IP, because we have switch connected. 1.11 I will give, and I'm not going to give any gateway, because we are not going to do the lab out of the. So that's 11. I will give this is 1.12. So very easy to remember. So we have IP19 IP config. First we check IP config. Yes. So ping the self test 192.168.1.1 12 is my IP. I'm pinging, good. Now go to the my neighbor IP. Okay, that's also reachable, great. Now my server is reachable or not, 111. So server also reachable, great. So what we have to test HTTP. So let's quickly configure, see how fast I can configure the server. We have these services on server, the HTTP, click HTTP, and these both are on. So I'm going to on only the HTTP, not HTTPS. Okay, not HTTPS. So I'm not changing this, I'm not editing anything here on server. Okay, I'm just switching off the HTTPS and switching on the HTTP, means only the 80 port going to be work. Let's open the, I'm going here HTTP, and I will open the browse. We will test. So tell me, for HTTP it will work or HTTPS, which one is work? Bolo something here. HTTP only work, HTTPS should not work. Let's test for HTTPS first. I have disabled that and this, and I want to test the packet. So before going this, I will simulate that and I will start packet capturing. So packet start capturing and I will expand this. Let's see what going to happen. So this packet went there, HTTP, and this goes to, this supposed to go there, and I'm clicking this packet. Can you see there's a header only? So what I'm going to trigger 80 port packet. So request timeout, again I will do this. Let's open this HTTP, and again I'm going to trigger this 192.168.1. and intensely I'm giving HTTPS. Okay, intensely I'm giving. Now packet trigger, can you see TCP packet trigger HTTP? Now packets came here. I just clicking, I just want to see what packet we have. What packet have? Can you see that? The header come with that 443 header, but there is no response from, the packet from server, because he is not made for that. We are timeout, reset connection. Okay, so no HTTPS response we can able to see. So I'm going to change this because we have enabled the HTTPS. Now I'm going to do, everyone concentrate. Now I remove the HTTP. I'm doing HTTPS, sorry, HTTP. Now I'm doing S, I removed, means port number 80, 443 they did not get response. Okay, let's go for that. I click that, wait, it's opening or not. Now packets went there from here to here. It came to here. Now I click this. I open that. He got the response. Can you see? Earlier it was not responsive. Guys, everyone. Earlier it was not responded. Now it's a response. They have the in layer only. There was a request from the in layer. That time there is no request was there, but now this is a responses, and you can see the response on here also, HTTP. Can you see, guys?
Yes.
Yes. So in the packet out layer, now the response come with the port 80. So the website supposed to be open now. Yes, website open. Are you see that? Tell me. Are you able to see?
Yes.
So now website is open because wait, cancel. Yes. This is dangerous. Okay. Now come to, yep. So let me open the website now. This is the website. What I will do, I will do some changes in the server. What I will do, I will do some changes in the server. Let me read. I'm going index page and I'm going to make this a little bigger. I'm not going to make it bigger. I'm going to add here CCNA code. CCNA 200-301. I'm going to save this. So I made some changes on the server. Let's see it's going to reflect or not. Let's see it's going to reflect or not. So I'm going to open this and trigger the packet again. So packet now moving to switch, come to, now it's going to be here. So let's see packet are, yes, we got the in and out both the response. Now it's supposed to come to my desktop and I have to see here CCNA code supposed to be reflect. Stop this. Yes, sometime you have to stop simulator because simulator is running on there, is going to be little slow. So can you see this packet reflect? Earlier it was not there. Everyone,
Yeah.
okay.
Yes.
So yes, so let's see I saw the header for the 80. What about 443? So what I'm going to do, I'm going to enable both. Now after that, once I enable this, and we will test from different laptop, or you can do the same also, that's not a matter. So I'm going to test again, and this time I'm going to do 192.168.1.11. This is without secure, without S. I want with the S because I was not able to open earlier. Do you remember? So I'm going to stop, and so I will write HTTPS colon 1. Do you remember I started the lab from HTTPS only? That was not successful. Now it's supposed to be successful. I hit this. Let's see the packet. Whether that time we did not see the out layer packet header. That's response we have to see. So we have to first open the simulator, run. Can you see here? Either that's a play, control play. Now you click this. Okay, and after that you again trigger the packet. After that you going to trigger the packet. Better you close this and open that again and trigger the packet. HTTPS 192.168.1.111, and we see the packet. Now packet is started from here, TCP. Now TCP came to here. I will, once the packet here, I will click that packet. I want to see what happened to the packet. You can click every time and you can see the layer. Now my response is ready. Guys. So my response is now it's if you see here, I just want to show you the beauty of that. This is they requested as a source any port, higher any random port they taken, destination 443. Now source is 443, means response generated from the 443 that's enabled in the server, and any random port which is selected. You can see here HTTPS the logs are generating for same. Can you able to see here? Now let's check. let's check for that how this is done. Now we will go, yes, now the packet is open. So I want to test whether it's reflected. I want to change something here on, we will do the edit hello world. We will do earlier, first you see what changing. If you click hello world, this copyright or small page, so there is a hello world, it's not opening. You just off the simulator, because simulator go to real time. Now open this, I will go to back, small page I'm opening, it's a hello world, it's telling. So what I'm going to change this from server end. So you can do this kind of lab also testing. You can do your name also testing, just I wrote. Okay, now is this, save it this, do yes. Now trigger your web server from anywhere, we trigger this, go that and go for a small page. Now ASU testing, can you see this lab is working fine, guys? And so by this I'm done. If you guys want to ask me question regarding the packet header and this stuff, you have to trigger your packet. While you are triggering your packet, your answer not going to be show you as soon as possible, because the it will show you packet started from here, then it goes to and generate the response. You need to study each and everywhere how the packet formation going to be happened. I showed you what's the process and how to capture this today. From next class we're going to study for each and every packet, layer 2, layer 3, layer 4, everything, each lab with the header detail, and we will study according to that. We're going to set up our lab and other stuff. So I'm going to stop my recording now, and we will see you in next class with the next topic, that is the CLI command and the IP addressing. Okay guys, so let me stop recording first.